Hi everyone, welcome to our first week of distance learning. This week we're going to be focusing on probability of independent events. So what is probability? Well, probability is how likely something is to happen. The probability of an event occurring is always between 0 and 1. A probability of 0 means the event will never occur, and a probability of 1 means the event will occur. And of course we can have anything in between those two. The closer a probability is to 1, the more likely it is to happen. The closer the probability is to 0, the less likely it is to happen. Outcomes are just our possible results. Probability can be broken down to two types, theoretical probability and experimental probability. Theoretical probability is what could or should happen mathematically. Experimental probability is what actually does happen when you perform an experiment. Our focus this week is on independent probabilities. So independent events is where the outcome of one event does not affect the outcome of the other events. Dependent events is where the outcome of one event has an impact on the outcome of the other events. Compound events is basically where we're taking more than one event and putting them all together and trying to find the probability of all of these different events happening. And when we do this, the probability of the first event gets multiplied by the probability of the second event. So let's take a look at some examples. Suppose you roll a red number cube and a blue number cube. What is the probability that you'll roll a 3 on the red cube and an even number on the blue cube? All right, well, we're going to assume that these cubes are 6-sided and numbered 1 through 6. So in order to find out the probability of just rolling a 3, well, there's only one side with a 3 on it. So 1 out of 6 would be our probability for rolling that 3. To roll an even number on a blue die, right, well, there are 3 possible outcomes. We could have a 2, a 4, or a 6. So the probability of rolling an even number would be 3 out of 6. We're going to multiply those together, and we end up with 3 over 36. Now when we're dealing with probability, we always want our fractions to be in simplest form. So 3 out of 36 can simplify to 1/12. We can also show our answers as decimals. So I can do 1 divided by 12 will give me 0.083, or I can convert that to a percent, which is 8.3%. Right, let's check out another example. Suppose you flip a coin, roll a die, and play rock, paper, scissors. What is the probability that the coin will land heads up, the die lands on 2, and you decide to go with scissors? All right, well, to flip a coin, there's only 2 sides, so your probability of flipping and landing on a head, okay, is 1/2. The probability of the die landing on 2, so again, we're going to assume it's a 6-sided die, numbered 1 through 6, and there's only one side with a 2, so the probability would be 1 out of 6. And the probability of picking scissors, well, there's 3 options, right? So 3 possible outcomes, rock, paper, or scissors. So that probability would be 1/3. We can multiply those together, and we end up with a probability of 1 over 36. It's already in simplest form, but we can go ahead and convert that to a decimal or to a percent. All right, let's try another example. Hector has 15 shirts in his drawer that are all the same size and shape. 6 shirts are white, 4 shirts are blue, 3 shirts are red, and 2 shirts are green. What is the probability that Hector will choose a white shirt, put it back in the drawer, and then choose a green shirt? All right, so we want to look for the white shirts, right, and the green shirts. So 6 of his shirts are white, and 2 of his shirts are green. And there's a total of 15. All right, so 6 shirts are white, 2 shirts are green. I'm going to multiply those together. And before I do that, we're going to go back and kind of an indication here that he put it back in the drawer before picking another one. That's an indication that this is an independent event. That means that him picking this one has no impact on him picking the next shirt. Right? When he puts that white shirt back in, there's still 15 left. Right? So now we can go ahead and multiply these together, and we get 12 over 225. And then we can go ahead and simplify, and I can get 4 over 75. Sometimes people will go ahead and simplify fractions first and then multiply. It makes it a little bit easier. Your choice. All right, next I'm going to take this and I'm going to convert it to a decimal and then to a percent. Depending on how the question is asked, you may want your answer as a fraction, as a decimal, or as a percent. All right, we're going to do one more example together, and then there's some practice opportunities for you. In example 4, we're talking about Hector again. And again, he's got 15 items of clothing in his closet that are all the same size and shape. This time he has 6 shirts, 4 pairs of pants, 3 sweaters, and 2 hoodies. Hector closes his eyes and reaches into the closet. What is the probability that he selects a sweater, replaces it, then picks a pair of pants? So again, we have that key phrase, replaces it. That means he's taking a sweater, he's putting it back in, and then picks a pair of pants. So the number of items of clothing he's picking from doesn't change. All right, so he's picking a sweater, and he's got 3 to choose from, and then he's picking out of the 4 pants. All right, so the probability of picking a sweater would be 3 out of 15. The probability of picking a pair of pants would be 4 out of 15. Multiply those two together, we end up with 12 over 225. And again, we can simplify that, which again gives us that 4 over 75. We end up with the same answer this time as we did last time. All right, now, again, I'm just going to convert those. Oh, in this case, I did not convert those. It's going to end up being the same decimal and percent as what we saw before. So in this case, it was 4 divided by 75. So we have 0.053. So, whoops, let me go up here. So we have 0. Sorry for that interruption, guys. Okay, so let's go back to where we were. 0. Oops, I lost my pen. Try that again. 0.053, which we then can convert to a fraction, which is, or I mean a percent, which is 5.3%. Okay, and that is the end of our video. Go ahead and make sure you check out those practice opportunities that are posted.